Hello, everyone. My name is Leo. I'm from SuperAnnotate, and I'm super happy you're joining this webinar. We are waiting just a few short minutes for some more people to join, and then we're getting started. So yeah, hello everyone, and welcome to this webinar with SuperAnnotate and AWS. We're going to start with a short round of introduction from me and the rest of the panel here today. So my name is Leo. I'm heading up product marketing at SuperAnnotate. And with me, I have Alfred from AWS and David from SuperAnnotate. Alfred and David, would you like to give some short introductions to yourselves?
Sure. Yes, my name is Alfred Shen. I am a senior GenAI specialist here with the AWS. I focus on generative AI, and I am working out of San Francisco Bay Area.
Cool.
Thank you.
Hi, my name is David. I'm a solutions engineer at SuperAnnotate, and yeah, I'm gonna help show a demo today.
Thank you very much, David. So general outline today is going to be that I'm going to start talking a bit about both kind of SuperAnnotate, what we see that customers are doing today around kind of generative AI, fine-tuning, customization of models, what problems people generally run into, and how we think around helping them solve those problems on the data side. Then I'm going to hand over to Alfred, who's going to talk a bit about how Amazon and AWS helps their customers actually go from having, a data set to creating and deploying fine-tuned models and a lot of things around that. And then back over to David here, that's going to walk us through a little demo of how you can use SuperAnnotate to create fine-tuning data sets, easily transfer that over to Bedrock, and get started with fine-tuning and model deployment. So what is SuperAnnotate? I think is a good place to start. So it really sprung out of computer vision research made by one of our co-founders at the Royal Institute of Technology in Stockholm, Sweden, back in 2019. And we quickly established ourselves as sort of the #1 rated data annotation platform for unstructured data, mainly in computer vision, where we try to always stay on the forefront of innovation. And as you all know, during the last couple of years, or the last year really, generative AI has really swept through the machine learning community. And SuperAnnotate has stayed on the forefront of that as well, providing what I kind of described here as a multimodal AI data platform that enables dataset building and model evaluation for both large foundation models, large language model agent systems, and RAG systems as well. And here we're serving several of the leading foundation model companies that are both kind of building and developing these foundation models from scratch, but also enterprises that are building AI products based on them for external or internal uses. So a little what I'm going to talk about today is that AI has, of course, not really stopped with ChatGPT. A lot of companies are using that for several tasks, but a lot has also started on adapting these models to different other needs. And generative AI has started to open the door for a lot of different products built on these AI systems as well. So I'm going to start out to talk a little bit about the current state of AI as we see it with our customers, some of the challenges we that often face when working, especially with sort of the new things that are coming in the field, how we fit into the general AI pipeline as well. So let's get started. So what we see is that the complexity of type of AI systems that people are kind of building or fine-tuning today is really changing and increasing. Whereas previously, they might be fine-tuning of models for basic summarization or evaluation of reviews and other types of tasks like that. There's more and more movement away from that type of more generic solutions to really highly specialized AI models, which increase the demand for really industry-specific data. And that might be moving over to be able to analyze really complex technical documentation that existing foundation models are not capable to do, and where maybe even you as an organization are the only ones who have the know-how to really do that. In addition to those very complex stuff, we're also seeing that there's a system complexity that's increasing as well. Instead of just fine-tuning a model on a specific task, there might be a building of more advanced systems now. So combining several large language models, tool use, routing, and you get up to a place where evaluating these systems can become really complicated, especially with the tools that exist today and a lot of people use. And really training different components require much more complicated data, and you have that sort of interplay between pieces. And we're seeing a growth in multimodal data as well. It's not just text anymore, it's images, it's video, and a whole array of other input that also make kind of testing and building these training data sets much harder. And there's also a motion from building models from scratch to starting to adapting. And that's kind of the whole idea with foundation models. So with the models, as mentioned, like out there, not always having the best results on a company's specific data, there's a need there for the unique company data leads to unique models. And if you have that unique data, you utilize it, you can really create models that can outperform competitors by excelling in those areas that matter the most to your organization. There's also a growing need for customized model evaluation. There's, the leaderboards out there for models. They say a lot about how models perform in a general sense. Usually it's quite generic data, and it might usually not include niche data or, of course, not include proprietary data to your organization as well. So there's a growing interest and need in really undertaking those custom model evaluations, creating custom data sets. And bottom line is really that those companies who are the best at refining these models, the best at testing them, the best at integrating them, it really can build the best AI products, either internally to help them excel or externally to sell to others as well. So there's, of course, a lot of challenges that comes with this. This is a setup that we often see customers that come to us using. If you want to build your data set to fine-tune a model, or you want to evaluate a model, you might have the model hosted in AWS already, which is a great start. But we've seen data teams kind of pulling data, exporting data over to an Excel sheet where they're annotating, rewriting. They might have QAs working in this as well, and a whole lot of people, and it becomes quite quickly a big mess to manage and maintain. A data scientist might pop in here, try to curate a data set that they transfer over manually up to AWS again for training and execution. And this is not uncommon. Seen it in startups, in enterprises, and even some of the bigger foundation model companies that you've heard of have at one point, or some still today using a workflow like this to build parts of their data sets. And it really becomes even more complicated because if it's just text you're working with, that's not too hard. But all AI products are truly different, and standard off-the-shelf tools can't really handle, images. You might put a link into your Excel sheet, or multiple turn conversations can be harder as well. With video and everything else, and as well if you have a bigger system. I'm going to start using one Excel sheet for the initial prompt, a second one for retrieval, and it's not really built for evaluating those types of systems. And a lot of other kind of platforms out there as well are also only built for kind of evaluating the standard single turn AI conversations, or building data sets for kind of multi-turn, but not really when you start building more advanced systems as well. And it's not just problems with the individual AI team. There's also problems that are coming sort of on the organizational level as well. If you're a company that we've seen that building many different kind of AI use cases, they're moving to different teams with their specialized projects, might either build tools in-house or buy specialized niche tools for that specific thing. And you can end up with this sort of patchwork of different tools for different AI teams. With duplication and all the inefficiencies that come with multiple procurements and handling that. It can be really hard as an organization to get some sort of oversight of what's going on, what data you actually have, models you're evaluating. And it can become really hard to scale up. If you get bogged down in all of these organizational challenges, executing an efficient AI strategy can be really hard. So what is SuperAnnotate doing to help kind of solve this problem? Well, we have a product that's built out of kind of 4 or 3 different core pillars, you could say. One of them is a UI builder. We call it Fine-Tune or Fine-Tune UI Builder. It's a place where teams can build out their own sort of data annotation interface that's can be customized to supervise fine-tuning, RLHF, evaluating agents, connect it directly to a model with model-in-the-loop support for multiple of these models at the same time. It's easily extendable. We have a bunch of kind of core components for image, for text, for buttons, but clients can script and build their own components from scratch for more niche needs as well. And complete with kind of assignment of work to experts, your own experts, other experts, or kind of service providers as well, with QA workflows around that. We're kind of trying to tackle this project management organizational headache piece as well with our product management tooling that helps you both kind of track everything that's going on, both within specific data annotation projects and across, that enables annotators, QA, and experts in your organizations as well to really collaborate with comment and chat functionality, to share feedback and track feedback, and group different type of experts as well, or across languages, exploring data, analyze what's going on. And this really can become quite important. And a lot of times, as I mentioned previously, organizations are trying to fine-tune or use their own kind of organizational know-how to build data sets. And where previously a lot of them have turned to maybe external service partners for building data sets quickly and outsourcing that, they're ending up in situations where data they want to fine-tune or train models on are so specific that they actually already hire every single expert on that topic internally. And then kind of getting that and starting to manage and organize those projects can become much more important, especially in a user interface that, maybe your engineers want to come into and help out with as well. But managing and building data sets are not all. We also work on kind of removing all those manual steps around kind of exporting and importing data between the different platforms, making sure that everyone can be up to date on what's happening as well. And that's why we have our pipeline automation tool in here. So with that, what kind of the end-to-end pipeline, what does it look like? You really need a couple of 4 different things to build and deploy AI products. The one is kind of building or adapting, fine-tuning, if you will, a data set that you already have. The second one is, of course, a way to train these models and efficiently manage and execute that process, to deploy and run those models and have inference that can be in-house or in the cloud, and have tools to evaluate as well. And in the workflows that exist today, we have AWS is a great way to handle sort of those 2 core pillars, but still kind of working with other tools there. But if we pop SuperAnnotate in here as well, we have AWS on those 2. We still have 2 pillars remaining, and that's where we kind of come in and work a lot. And this is a typical workflow that we can see a lot of our customers use, with easily import data sets from AWS databases to the labeling tool, distribute to annotators, setting up things like LLM as a judge or so on using this orchestration tool, toolkit for easily curating these data sets and sending it back up to the cloud and Amazon to start learning, training, alerting the team that needs to come in and do more things with these models, and really setting up this efficient loop to continuously iterate and build better models with their own data, with their own know-how. And this is sort of that end-to-end pipeline. So with that discussion about sort of the data and how we work around building that, I want to hand over to Alfred to talk a bit about how AWS works with it as well.
Thank you, Leo. So the data is important for any generative AI application, right? And so if you look into the AWS GenAI platform, next, Leo, please, you can see there's a platform called Bedrock. So what is Bedrock? Simply put, Bedrock is a managed service for generative AI. Through Rich Bedrock, you can access multiple models provided by different vendors with one single API. Now, of those models, as you can see, that some of those models come from the proprietary vendors, such as AI21 Lab or Anthropic, right? Others come from open source communities, such as Meta and also Mistral. Now, of those types of models, you can see that we have very sophisticated model, such as Anthropic's Claude 3.5 Sonnet. It has been one of the best model available today. Not only that, you can access to a lot of multi-model models. Not only you can generate text, you can generate image, right? Interpreted different type of modality of data set. And also you can access to the embedding models. If you look at the Amazon's model, like a Titan text embedding, right? You can embed text into vector space for different type of application. And then you can also embed image as well, right? Next, please. Now, when we're talking about current usage over here, one of the common usage is you send inference to any type of foundation model, right? And then you get inference results. But a lot of use cases require, for example, like you need to have model to understand your business, right? And sometimes there's a business regulation and constraint that you are not allowed to send your data outside of your domain, right? With sensitive data security requirements for certain business. And also the cost is another concern, right? Because do you really need all applications to depend on certain model, very powerful model for all the tasks, right? So that's the reason why people turn to fine-tuning, right? So what does fine-tuning do? Now, if you look at the second one over here, fine-tuning basically is use your label data, right? And then to fine-tune the model, so the model can better understand your business, right? And then the objective of those fine-tuning, number one is to enhance accuracy. And second one is to meet your regulation requirement. And third one is try to cut down the cost. Right? Three out of three main purpose over here. Next, please. So the question is, besides fine-tuning over here, we also have another method. It's called model continuous retraining. What it does over here is you take a model and then you continue to train on top of your data, right? Your own business data. And the model, to teach the model to not only to have the pre-trained all those features and capabilities, in addition, the model will understand your business. The difference between continuous model training and also the fine-tuning, they are fine-tuning, it has only understand your own business. With the continuous model training, it has pre-trained models intelligence plus your business intelligence, right? Therefore, the continuous model training will alleviate some of the challenges we have seen in the model fine-tuning, which is catastrophic forgetting. I give you an example, like if you ask a pre-trained model, like who is Elon Musk, right? And the pre-trained model will give you the answer. He's a founder of Tesla and also SpaceX. He's a very influential entrepreneurship. Now, if you want to fine-tune this model with some sort of, let's say, the medical data, right? Any type of pathology, radiology, and also any procedure over here. And then you go back to ask model, say, who is Elon Musk? And the fine-tuned model probably sometime will give you the answer, Elon Musk is a doctor, right? So I think that's the reason why some option you leverage continued model training instead of fine-tuning. Next, please. Now, after this model being fine-tuned or pre-trained, you need to service it, right? So the service of model sometimes is challenged, right? And particularly in the operation side, if you need to handle high volume, high availability, right? And then also the API and SDK, and also security guardrail, right? Because you want a model to act, to answer certain questions. You don't want model to give you answer some offensive, query or not appropriate topics, right? And so there's a lot of security mechanism you wanted to put together in terms of service the model. So in AWS, you could import a model into Bedrock with your fine-tune or continued pre-trained model. By taking advantage of the Bedrock's API, security, and also you do not need to manage the infrastructure, right? For any type of, like GPU, because itself is a very heavy lifting task. Now, if you can do a tab over here on the button, Leo, you can see there's some diagram over here. Next. Yeah. So in the case that you need to fine-tune it, you have quite a few choices of GPU resources. As you probably know that the GPU is important besides data, right? Because you need a computational power to run training job, as well as inference, right? On AWS platform, you have a wide spectrum of the choices of GPU resources. You ranging from the NVIDIA's from A10 all the way to the latest, the H100. And the Blackwell platform and GB200 will be available soon, right? Now, besides that, you have quite a few other choices on that. One example over here is the purposely built Trainium, right? It was provided, the chips were designed by AWS. It could achieve the similar performance as NVIDIA's A100 or H100, but you can help you to cut down the cost by 1/3, right? And also you have other third parties provider such as Qualcomm also supply the GPU resources for you. So you have wide spectrum of choices depending on your project and your budget and the model itself, right? Next, please. Now, if you look at could you do a tab over here? We can show the whole image. Yeah. If you wanted to choose to fine tune or continue train a very large model, let's say some of those models has a parameter over 500 billion or even higher, right? You need a cluster of GPU to work together, right? So we provide a service called Hyperpod, right? The Hyperpod basically will allow you to distribute your data. Let's say you have a very large data set, tens of trillions of tokens, and you need to fine tune a very large model, right? Like 500 billion or more, right? So generally you need probably 100, if not thousands of GPUs to work together. This Hyperpod basically is a HPC, high performance computing, designed for generative AI model training or fine tuning. So within that, you have a cluster, right, to manage this inter-process communication with the elastic fiber adapter, very fast network controller, and also the protocols. We have also protocol to manage the inter-process communication through NACL and MPI, right, and to work with the different devices. And on the top that you can leverage the PyTorch or TensorFlow, the framework to try and fine tune all those models. Now, on top of that, we also have a fast I/O over here through the FX Lux, right? So that the when you have a fast GPU over here, you also need to have fast I/O, so the GPU will not be sitting idle over there. The last, if not least, is the whole part is managed by the the simple Linux resource management, right? So you can handle some sort of interruption. It will checkpoint, and then the training job will continue in case certain nodes came down, right? Because a lot of time, those training jobs will take days, if not weeks, to complete. During the process, you might have some sort of outage, right? Or some nodes and probably is out of service. With this hyperpod, you can continue the job, without you have to go back from the beginning. Next, please. Now, so earlier we talked about the fine-tuning or continuous training. So today, I think we are getting into agentic generative AI. So what is an agent, right? Agent, you can look at as a task executor, right? It can help you to execute or carry out complex tasks. Traditionally, we leverage GenAI. We do it direct inference, such as serve as a personal assistant, chatbot, right? This is you send a query, you ask a question, and then the LLM give you the answer. Now we evolve into a RAG solution called the RAG is retrieval, augment, and generation, right? You have a LLM, you embedding your document or your corporation data into a vector space, and then you retrieve those information by Q&A, right? And it has been proved very successful. But in our real time, our problem is much more complex than personal assistant or RAG solution, right? So for example, if you wanted to ask any questions about what happened to Hurricane Milton, right? What's the damage over here? And most pre-trained language model will not be give you answer because they have a cutoff date, right? When they're trained, the cutoff date, they said that it's 3 months ago or even like sometimes even longer. They will have no information about what happened now or even moments ago, right? So at minimum, you need to have some sort of web search engine to find out those information associated with your topics, right? And another use cases over here is many of those pre-trained foundation model does not understand your business, right? If you wanted to ask any questions about what happened to my own business, right? And those model either give you hallucination or simply tell you that give up, saying that I'm sorry, I don't know the answer. So what agent does over here is can connect all those complex tasks, such as web search tools, right? And also talk to your own database or knowledge base, and then aggregate those information together and help you to carry out the complex task. Next. Now, from the AWS standpoint, we are currently in the full mode to support this agentic solution, right? And so we divided this kind of journey into 4 different phases, starting with the single agent, right? With multiple tools. Earlier you mentioned that from single agent, you can call the web search, you can call database, you can even call a RAG, treat RAG as a RAG agent, right? Then the next phase will become a multi-agent collaboration, because you could think about that the agents depend on other peer agents to collaborate, right? Not only to carry out more complex tasks, but at the same time, it can increase this parallelism so that you don't want it to have a kind of serialization execution, right? Because a lot of tasks require real-time or near real-time performance. And we get into the next phase is asynchronous, right? Agent doesn't need to work at the same time, right? And they could do a little bit asynchronous mode, because each of those agents for different tasks, it will take a longer time. Sometimes you have a direct dependency, others you can act independently, right? And then it requires some sort of orchestration tool to connect those agents, either form a tree, like today that is very popular over here would be a channel thought process, right? And then evolve into a different phase of those tree structures, such as tree of thoughts and even graphical thought. And then eventually get into more autonomous agent, which is phase 4, right? And then there are some research paper, as some of you probably already know, that is based on the more advanced reasoning capability, such as Monte Carlo search, and plus a few others. Right. Next, please. So again, all those journey, not only talking about the model fine-tuning or the continuous training or even agentic solution, data is a key over here, right? The whole journey over here, the data quality is important, right? And today with the SuperAnnotated, we are able to not only annotate text-based data, and then you can also help you to annotate the other modality data, such as image, right? Eventually in the future will be video, voice, and etc. Now the besides data quality, data security also a key over here, right? And today a lot of businesses, you probably won't allow to submit your data for any public API, because those data could potentially be used for future model training or for other purpose, right? Now, in AWS environment, we strictly prohibit us or any team to leverage data, right? If you have inference data, you submit to API over here, AWS Bedrock API, we catch it and then we purge it out, right? And then we will not use any of those data for any type of model training, either within AWS or third party. Now, besides that, the data security also is a key over here, right? And within AWS platform, as you probably noted, your data transit or even at rest, those will be encrypted. And then data will always stay in your own VPC, right? And nobody else can access to it. And you manage your own key. Next, please. So besides data security over here, guardrail is also important. What is a guardrail or guardrails? So the guardrail is basically to validate a query or even the response from any type of foundation model, whether the content contains some sort of either PII or PCI information, sensitive information, or sometimes offensive information, right? So guardrail itself is a service within the Bedrock. All those definition of those offensive, policies, configuration, or verbiage, you can customize it, define it, right? And it serves as a kind of content moderation or filter, right, to help you to safeguard your service or product, so that you will not be, certain undesirable result will not be leaked out back to your customer. And this is a part of the responsible AI policy within AWS. Next, please. All right, that's it. Now back to you, Leo.
I see. I was muted there. Thank you very much, Alfred, for that description of AWS and how your solutions can help people really train these and fine-tune these models quickly. So before handing over to David, I thought I just wanted to showcase some of the things we help companies achieve. And here, actually, I know, Alfred, you recently mentioned, maybe sometime in the future, people would annotate and fine-tune video data in GenAI, but that's actually 12 Labs here, one of our big customers are working with exactly that. So building video multimodal models using data from built with the SuperAnnotate tool, but really working with kind of companies across the range in generative AI or adapting generative AI as well. So with that said, I want to hand over to David, who's going to take us through actually a real example of SuperAnnotate and how you can use it.
All right. Thanks, Leo.
And there, over to you, David.
Cool. Thanks. Let me just share my screen now. All right. So today I'm going to walk through an end-to-end guide that takes users from creating data from scratch all the way to fine-tuning an LLM model on Amazon Bedrock. So that being said, let's get right into it. So as a user with at least a team admin role in SuperAnnotate, when you accept the invitation link to join the platform, you will land at a page like this by default or by creating it. And from here, you can actually create a new LLM project, which I will do, and title AWS Bedrock Demo. From here, you're going to come to a page where you can select from popular templates for project types such as model comparison, chat rating, and such. But for the sake of this demo, I'm just going to build a form from scratch. On this page, your goal is to create a custom user interface that annotators for your project will see, right? So on the left side here, you have building blocks and you have the UI form in the middle. The building blocks on the left build a user interface that the annotators, QAs, and whoever else in this project workflow will see, right? So for instance, you can make it such that the annotators will see some kind of external components, such as some PDFs maybe, or some URLs, and to build their item off of. Maybe let's just say a text area to write a description or something about these external sources, right? But you might also have something more QA specific. So maybe a QA will go into the item after an annotator has done their job to rate the annotator's work, maybe by voting or by rating by stars. But for the sake of our project, we're going to just be creating question and answer style data points to fine tune an LLM such that it refuses to answer questions that require any mathematical computations. Therefore, I'm going to create a text component here just for question, and I'm going to call question area, and you will see it as question. And following that, you're going to have the answer area, which I'll call answer. So after that's done, in the next page, you will be able to define any interactions within components as well as custom functionalities like sending webhooks. But for this case, because it's simple, I'm just going to publish the form. And here I can give item names and how many of these items I want to make by default. So I'm creating 128, but users can create as little or as many as they want to fine tune the model on. And so I'm just going to publish and create this. All right. So at this point, I'm going to go over into the setups tab, and you can invite others to start annotating these items, right? So in contributors tab, after you've already added them to the team, you can start sharing this project with some of these annotators, QAs, and such. And also, what I would also recommend doing is going into the general tab to determine how the annotators will be able to request these items. So right now, they're going to request by category, but since I don't have categories, I'm just going to make sure that they can automatically get assigned a batch size of 3 new items every time they request something, right? We could always change this batch size as well. All right. So going back to projects, after these annotations are completed, I already have a completed project here with all the data points. I can actually go over to maybe look over some of these items in the Explore tab. So I'm going to click this Explore tab on the left here and check that the items look right. And over here, I'm able to actually select the components that exist in my project. Over here, specifically, we have question area and answer area. And I just want to make sure that the data looks, for the most part, right. So when it's asking something like, what is the function of the heart? I can see that my answer says something like, oh, the heart pumps blood throughout your body, delivering oxygen and nutrients, yada, yada, yada. But when it comes to something that is mathematically, requires some kind of mathematical computations, it should reject it, right? So compute the first product of the first 5 prime numbers, but the answer is, sorry, I cannot perform such multiplications. So from a bird's eye view, I can tell that this is working as we expect. So after we verify the data set, we can now go into creating an automated pipeline that will format and store the data points we just created on S3 for Bedrock fine-tuning, and then 2, even from our own platform, trigger a fine-tuning job as well. So I'm going to go over to the Orchestrate tab on the left here. And before creating any pipeline, I'm going to go over into the Actions tab on the upper right here, and then the Secrets tab right here. So In order for our pipeline to work, obviously, if you're going to use S3 and such, you need to specify, several secret keys and values, and these will contain the sensitive information that you wouldn't necessarily want within a publicly facing or, more available actions in our orchestrate, right? So if I look into it, we can see several things, like the AWS access key ID, secret access key. I can have them here. I also have to specify things like, what foundational model on Bedrock am I going to work on? Where is the bucket location I'm going to load and pull from? And for some buckets, you might need an external ID to make sure that, we can access these. And on top of that, other parameters such as region name, roles, and SA token, which is our own SDK token that you can see in your team setup tab. One thing that is optional here is going to be the Bedrock role ARN. If you already have one, we can use what you already just import from here. But if you don't, we can help you create one as well within the action. Okay, so let's go over into the actions itself then. All right, so I'm going to create new action here. And if I create a new action, these are going to be what will trigger from our pipelines once some event occurs, right? So I'm going to be prompted, if I create an action, to either create from scratch or use an existing template, right? In this case, we will use the 2 Bedrock templates that are available. First, you're going to create an action to upload the data to S3, and then the action to fine-tune the model that you want. To show an example, if I click one of these actions, I'm directed to an action that does exactly what I described, uploading the Bedrock format data to S3. And if I just look over it, you can see that it's written as a containerized Python script with the necessary packages and the Python version on the left here. And just going over very, very quickly, I'm formatting the annotations on our platform into the Bedrock format. And then afterwards, I call S3 with Boto3, and then I format, combine JSONs that I've created into a JSON file that it can use. All right, so I'm going to get out of this screen. So once you created those actions, and I've already gone ahead and created these actions, I'm going to go over into the pipelines tab here, and then I'm going to create a new pipeline. So our orchestrate pipelines, like I stated previously, it's built around events that trigger actions, right? So in our case, I'm going to say that when our project is updated from any status to fully complete status, for specifically our demo project, I am going to trigger an action that first uploads the Bedrock format data to S3, and then fine-tune the model. Along with that, for these actions, I'm going to attach my secret that I've created so that it can pull from the secrets for the parts that it needs. And I can just name the pipeline as something like Bedrock fine-tuning. Cool. All I have to do now is go over into the projects tab. Right now it's in progress, but if I switch it to completed, the action should kick off in our orchestrate pipelines. And if I go over into the tab where I click there, I can actually see the progress of the action that was just triggered. Over here, we can see that, for instance, the upload action from that pipeline is successful, and so is the fine-tuning Bedrock model. And if you actually click into any of these actions, you can also verify the input, output, as well as the input, output, or any of the other actions as well. All right, now that we know that this is done, I'm going to go over into AWS Bedrock, see what's going on, right? So this is the Bedrock page that you can see right in front of you. And if I click on the left here, under foundational models, I have custom models. And if I go over into jobs, I can see that I have 2 jobs training right now because I kick off the orchestrate for both of those pipelines that I've created. But once it trains, it'll actually move on over into the models where you have now a customized model. And let's say you want to deploy this so that you can start invoking the endpoint, maybe just like verifying, validating that it's working. You can click on the model that you want press purchase provision throughput, as this is a way to actually deploy any customized models. And in this page, you'll be able to enter the name, which model you want to deploy, as well as like the commitment term, right? So if I do like no commitment, you'll get a pricing structure, and then you can purchase the provision throughput. So I think this kind of wraps up the end-to-end video, or the end-to-end guide from creating from scratch to actually deploying a model. So hope you enjoy the talk, and I'm going to give it back to Leo.
Thank you very much, David. So we have chatted a bit about today, both sort of what we see that companies are doing around AI and AI adoption today, some challenges a lot of people are running into, how we work around solving them, and then of course seeing how AWS works around enabling companies to really train and deploy these models, and seeing a wonderful demo from David here. So right now, we'll start over a little question and answer sessions. If you have any questions, feel free to just write them in the Q&A chat, and we'll make our best on answering them. I see there is one or two questions in here. I think one that you could potentially start out with, Adam, someone wondering around like how they can go about buying and getting started with SuperAnnotate. Is that like through AWS? Is it through us, or what can you say about that, Adam?
Yeah, good question. We'd love to get in touch. You're going to get an email from a member of our team on the SuperAnnotate side, so please engage that person. And then, I think you should understand how to get your AWS stuff going as well. But we'd be happy to work with you directly.
Thank you very much, Adam. Another thing that I'm seeing here is also sort of how it integrates with AWS. We have a couple of ways to connect to AWS, and there is both the thing that David showcased just recently. You can set up these sort of custom integrations, but we already connect directly to AWS as well using a native integration. And that's a way to ensure that if you're kind of looking to build out data sets for more sensitive applications, you can connect directly to your data set. All the data remains in rest in your AWS instance. It's only displayed within the SuperAnnotate tool directly. Let's see. Do we have anything else? Yeah, around customization. I talked a bit about sort of the customizable user interface that we have in the tool, and that David showcased a bit. You can set up images, video, text components. It really goes a lot beyond that as well. So if you're training AI agents or similar, you can easily set up interface. You can connect it to different types of tools, like a RAG database or other types of tools directly from this interface to see input and output, and kind of create more dynamic components that can appear and disappear depending on the trace of the model. I think that was potentially all the questions for now. So I would like to say thank you, everyone, for attending this webinar with SuperAnnotate and AWS. It's been a pleasure having you all here. As Adam mentioned, we're going to reach out to everyone with a recording of this meeting as well. So if it's something you want to share with someone else or look over again, feel free to do so. Thank you all.